I used at the U of A immediately as I joined planning systems. So
Interesting. And we'll touch more on your work with academia in a little bit, but I'm sure that is also another influential moment for you to come in with that skill set.
yeah, I mean, I think part of why I was hired was that, I did have, a diverse background. I did more than just the coursework, right? I tried to find additional things that I could do that would help me in my job. So, laying out a PCB board and having it manufacture and building it. I knew how to solder, right? These are not things that they teach you in college, but these are skills that you can leverage, when you enter the workforce. So definitely, and I had a great professor and he really pushed us, to do these things. So I think, having the right people in your life can make a big difference.
What ultimately brought you to Microchip?
I worked a lot with microcontrollers at planning systems. And, that was in Mississippi. So I wanted to get back to Arizona where, I grew up. And I was reading E Times one day, and there was a job posting to come to Arizona and work for Microchip doing microcontrollers. And I'm like, what a fantastic opportunity to, I was a user and a developer. What a fantastic opportunity to now be on the manufacturing side of it. And, obviously I've been here 30 years, so it worked out really well. And it's been a fantastic job.
So what did you come in to start doing? Are there any specific projects that you feel especially fond of or nostalgic about?
If I look back over 30 years, so I'm a big fan of Lego. I grew up using Lego. I still, build sets today with my kids. And we did a project with Lego for Mindstorms where we added a coprocessor to connect to Apple devices. And, I got to go to Denmark and visit corporate Lego and, go to the corporate Lego store. And it was just, for me, it was a fantastic opportunity. If I look back in 30 years, that was probably one of my most memorable, projects that I worked on.
Yeah, it's a almost like a pilgrimage for many folks
Yep.
to
Yep.
get to
It
go do
certainly
that.
was.
That's very cool.
Yep.
Can you tell me about your current role in development systems?
So, in development tools, we are responsible for developing all of the tools for Microchip's devices. So these could be programmers, debuggers. We also develop software tools, so integrated development environment or IDE. We develop compilers for our own products. And then we also manufacture the evaluation boards. So it's anything that a developer might use to evaluate Microchip or develop, applications on Microchip. My group supports for all of our business units. We have about 25 different business units, covers everything from microcontrollers to FPGAs. And so my group creates a lot of the support software for that.
So I have to imagine you've seen a lot in the last 25, 30 years of the evolution of those things. What has changed the most radically, and what sort of fundamentals have stayed ultimately true for you?
So I think one of the biggest changes, Daniel, has been that the IP on the chips themselves has got a lot more capable. A lot of people are probably familiar with ARM and Core Site IP. You can now dive into timers and internal counters in the chip itself. And, the chip can stream data out of itself. I mean, when I started, your IDE had a single page and you could see the RAM and you could see registers, right? And, you had limited breakpoint capability. And you didn't really run RTOSes in that day. It was just a main loop and you kind of just figured everything out. And I think that as applications have got more complex and as the chips themselves, the technology has evolved, I think it allows somebody who's creating, before you were creating a mouse, right? Now you're creating, a thermostat that connects to the internet, right? And it has a graphics display. And the tools that enable you to combine all of that technology together, first of all, and create it, and then second of all, be able to debug it, that's kind of where the technology has advanced is really the tools to enable developers to create these substantially more complex applications.
I'm curious because I don't often get to talk to folks who are involved in like dev board design, but dev boards are such a staple of like that prototyping research phase. What separates a good dev board from a great dev board?
A good dev board allows you, it's ease of use, I think, Daniel, is how easy is it for me to evaluate that, device in my application, right? Having all the appropriate test points and providing all of the access to the different features of the board. Let's say that, this microcontroller has this USB peripheral, but I don't have a USB connector on the board, right? So just making sure that as a developer, I have access to all the different pieces of it and expandability, right? Because an eval board, let's say a microcontroller eval board, is very basic, but I might want to add Bluetooth to it. I might want to add Wi-Fi to it. I might want to add a sensor to it. So does the eval board provide the access to those different features, right? And what Microchip focuses on a lot is how do we make sure that we give all of the developer access to everything that's on the chip, not just something very simple.
Yeah. Okay. I could see it. Like full functionality, but also still easy to use and maybe not overly complex. I'm curious, kind of the same question for an IDE. What makes a good IDE different from a great IDE?
IDEs evolve over time. What was really good, when I started 20 years ago is quite different from today. So I think today, developers get it's a little bit like religion, right? Developers like a particular application. I have developers that still use VI, and it's the tool that they've used forever. But I find that a lot of open source tools, right, really encompass the needs of all developers. And what we see a lot is like students when they come out of school, they've used VS Code from Microsoft. And so, rather than Microchip, we used to be on NetBeans, which is, 20-year-old kind of technology. We've migrated to supporting VS Code. It's lightweight, it's fast. There's 28 million software developers in the world today. 14 million of those use VS Code. So, aligning, our tools to the platforms that developers are most comfortable in, right? They don't have to relearn a tool. They get to market faster, right? And it's overall, it's a better experience. So, we look to the technologies that most clients are using.
What is maybe, I have to imagine you work with a lot of different clients, different industries, different geographies, different, mindsets. What's been maybe the most surprising development environment that you've come across?
I think the thing that's probably had the most impact, and I look at it from two ways, is AI, right? It helps developers be more productive, right? And so it's an assistance tool, but it impacts the end application itself, right? Can I create this feature more quickly using AI inside the chip? But like I said, can I use AI to make my development process much quicker? So I think the advancement of AI has probably helped considerably more than probably anything else that I've seen personally. And I was skeptical when AI came out. It's like, I don't know what this is. And I was thinking that AI is, I'm going to embed AI in my chip.
Sure.
But what I found out, and with a lot of work that we do here at Microchip, is how AI helps assist me in doing my job better, right? Or quicker. And can I get more done, in the same amount of time? So from a tools perspective, we look at how do we integrate AI to make the developer's life easier.
Where do you think, as of today, the lines are for where is it helpful and where is it maybe more aspirational or a novelty? Like, at what point can I just say, write me code for this and then get the code I need versus, respond to my emails so my manager knows I'm working and I can just focus on my code?
I think that AI as an assistant is very helpful, right? I don't think today, I don't think AI replaces anything. It always requires, a second level of effort. So if it can help me get 70% there, and then, I take the ball, 30 more feet and score the touchdown, then, it's done its job. And so from a tools perspective, that's what we look at, right? Can it help me do autocomplete when I'm typing in, a string, a line of code? Can it, comment the code? So I don't have to go back and comment code. And what if I see a strange piece of code? I can ask it, hey, what does this code do? And it come back, and it tells you. So I think as an assistant, developing code, I think in a microcontroller is a little bit different than using AI to develop code, let's say for Windows or Linux operating systems, because that's kind of a fixed set of APIs. With a microcontroller, you're doing a lot of, different things, UARTs, and they're very specific to the architecture. And so code generation for me is not quite there with AI, but definitely everything else wrapped around it. Even checking code. AI does a great job of taking a look at your code. For instance, we ran a set of code through a chatbot. The function call had greater than in the name of the function call, but the function was actually generating a less than. And so the AI came back and said, hey, your code looks good, but do you know that you're calling a greater than function, but calculating a less than? And so, it's like an extra set of eyes. It's an assistant to help you. Yep. Yep. And we've had developers that I've used this code for years and years and ran it through the chatbot. And, probably one of my best developers came back and said, yeah, it found 2 bugs that have been in my code for like 10 years. And he didn't even know, right? So I think, and it's good for, as much as you'd like for a test to be 100% comprehensive, right? You've always got corner cases that you can't predict. And the AI helps fill in, those corner cases. So I think it helps you in the end produce a better quality result.
And just getting good and comprehensive, 100% comprehensive test scripts is, it's always been kind of a unicorn, and it sounds like it continues to be one, but at least you can hopefully plug some of those gaps that, like, editing your own work is hard, editing code is hard, so, and reviewing code is hard. So finding a better way to do that, or another vector from which to approach it, is very helpful.
Exactly, right? It just gives you another set of eyes.
From my perspective, it really sounds like microcontroller development overall and embedded development overall just continues to get more and more complex. How do you balance for developers as you're creating these systems, enabling that complexity and turning on that complexity while also not over complicating the whole process for them?
So when we look at the applications, you have a massive set of content, right? I might have a graphics stack, or a graphics display that I need software for. I might have a TCP/IP, an Ethernet port that I need a stack for, and I have all these sets of peripherals that I'm using. So our approach is to allow the combination of the content, so all these drivers and software stacks, allow the combination of all those for an application to be easy and simple. And then the developer's really focusing on the glue, like the main application that ties all those pieces together. So I don't have to be an expert in graphics. I don't have to be an expert in Ethernet or USB or whatever it might be, because the software is doing, the software that the manufacturer provides does all kind of the hard piece. You're just, creating the main loop that ties everything together. So from our perspective, it's, can we create all the building blocks for people to combine? And then that way they don't have to develop that. It makes, the time to market, again, much, much shorter.
How much do you rely on like open source movements versus kind of keeping everything in-house?
I mean, it's a balance. Sometimes, we have IP, which is, specific to Microchip. We have a lot of, for instance, in automotive, we have a lot of the drivers for some of the buses, which are proprietary to Microchip. So some of that's internal, but, things like, Ethernet, air tosses, USB stacks and things like that. There's very good open source versions of those, and we want to make sure that it's easy to, integrate those into Microchip, especially, when you get to Linux, everything is kind of open source. And as Microchip's growing into FPGAs and 5-core and 10-core 64-bit parts, right? Being able to support open source and combining all those elements together is key. So I think open source drives a lot of technology, and I think it makes a developer's life easier because you can get so much content, right? Beyond what Microchip could develop ourselves. There's so much content on the web today. It's amazing, and it's so helpful to a developer.
When you look at the whole ecosystem, kind of start to finish of concept to finished product, how much do you see developers playing well with like hardware designers, and how does that handoff occur? And follow-up question, how do you make sure that handoff is seamless?
From what I see, most companies don't really have a pure hardware developer, and all that guy does is create a schematic and a layout, right? There's always the interaction with the software side of it. So, for us personally with our tools, we have a hardware, we call it a hardware engineer who does the schematic and the PCB, but they also do the low-level firmware, that does all the drivers for the different peripherals. Then I have another team which does the application software on the hardware, right? So it's not the drivers, it's not the I/O pin driver or UART driver, but it's the application that ties all those together and then communicates to the outside world, which in our case is an application on a PC. And then I have another group that does the development on the PC, but they all work together. So, engineering and software development's a team sport today, right? It's not an individual effort. So you have to have these teams, and they have to be able to collaborate so that, when I design the hardware, it works with the application firmware, it works with the application on the PCB. And so it's got to be kind of a higher level, holistic view of the application rather than just the individual pieces. So the hardware engineer knows how to write software. Our software engineers know how to configure the hardware. So everybody kind of has knowledge on all of it. So even with a larger company, right, we're still not just hardware, just software, right? It's always kind of a meld of all of them. I think a lot of companies are in the same boat.
I think that's fair to say for sure. Even like startup-y type folks have to sometimes do both. Keynote speakers for Industry Tech Days are brought to you by Mouser Electronics. Delivering the newest electronic components for design, Mouser is your global authorized distributor for millions of components from over 1,200 leading manufacturer brands. Jumpstart your designs at Mouser.com. What sort of skill sets do you see as essential for someone coming in? It's a team sport. Maybe I'm just a goalie, but it's like, okay, do I have to go be a forward or something? What are some of these unique skills that you think everyone on the team should have?
So we talked about collaboration and working in teams, and I think the last 3 or 4 years have been really challenging, right? It's creating a lot of introverted people, and so getting people to communicate and work well in teams, so that's one thing. I think fundamental, right, is a basic problem solving methodology, right? How do I attack a problem, and how do I get the right mindset to solve it? And that's when you're in school, developing a really comprehensive, problem solving methodology is a little bit challenging, and I think you have to have that first year to really help develop that. The other thing is change, right? Things change pretty quickly, and you have to be comfortable with change. And at Microchip, a lot of the things that I challenge my team on are, why did you make that decision? And, why did we not make this decision? And often, we change directions a little bit. And so I think being comfortable with change is really important.
I think it's essential, like survival skill in the workforce today. I think it's more than important. I think it's, it's make or break for people.
Everybody comes out and, I can write in Python or I can write in JavaScript. And, those things, I wouldn't necessarily say, that's a skill set, but I think it's soft skills, right? How do I communicate? How do I work with the team? things like that. And uh, I don't necessarily get that at school sometimes. So that's why we like to see, students that come out of school that they participated in a club. I was on a robot team. I did multidisciplinary. So I did a robot, which is mechanical, and electrical. And so we like to see students that do these extracurricular things and encourage that.
Yeah, they were able to collaborate cross-functionally.
Yep.
It's maybe the mouthful way of saying it. As you're developing these tools, I'm sure you have planners and teams that are trying to kind of see the future of where this is going. How do you stay up to date and connected with the people that are actually doing this, the people that are using your tools, and how do you start to build a roadmap for where you want these tools to go?
So we do Microchip does training all over the world all the time. Um, so we have a lot of feedback from clients and from ESEs or FAEs, field application engineers. So we have a constant, pipeline of that. We have a forum that, for Microchip where people come in. But here at Microchip, we probably have several thousand people that use our tools to develop on our microcontrollers, and they're developing, reference designs for, customers to integrate into their systems. So we get quite a lot of feedback, both internally and externally from the usage. All of our tools have a mechanism to provide the feedback, to us. And then it's working with our business units on new products that they're developing and what do they see. So for instance, on a digital signal controller, which is essentially a DSP, right? What is it, a new trace in being able to get data off the chip, right? So we look at, they're developing an application, for higher performance for their clients. How does our tools then accommodate that? So they have some vision and we use that as well. So lots of avenues, for visit. And then now that we're going out to academics, now we get to see from an ease of use perspective, how the tools can ramp up somebody that may be new to the tool and maybe not quite familiar with, programming a microcontroller at all. So we get feedback from a lot of different perspectives.
Do you have a philosophy of onboarding? I imagine onboarding like a undergrad is maybe a little more handholdy than onboarding a 20-year senior engineer, but maybe not. What's kind of the philosophy of getting people started?
Obviously, we want them to train in the tool sets for using, but I think the thing that onboards somebody the quickest is to give them actually a real project, like a real task, not that they're going in and poking around and doing things, but we'll give them a real task. And, there will be a senior engineer that sits with them and helps them, work on that task. But I think without tying their learning to something that is actually going into a product, right, I think the ramp is much shorter. So everyone that comes to work with Microchip, whether, they're straight out of school or they've been doing stuff for 20 years, they get a project, they get a feature that they're going to implement as part of the tool. And that, I think, ramps people the quickest, but often a lot of the learning is your systems, right? What is my version control system? What is my build system? What tool chain am I using? And, those things are very difficult. And that changes from, company to company. Everyone uses a different version of things. And so you have a lot of learning there as well.
Some of the things that even just like file architectures sound so mundane, but can be make or break for a project if you don't do it well.
Yep. What's my repository structure? Am I using Git? Am I using SVN? There's a bunch of different tools. Even within Microchip, trying to consolidate people down to a set of these tools is difficult because, today we're 22,000 people worldwide. And they've been doing a certain thing for, a while. And when you do acquisitions, they have a different set. And so, it's how do you bridge all this stuff together? And that's a big challenge. And it creates quite a learning curve.
What's the balance of, for you, tops down, here's how we're going to do this file architecture or repo strategy versus giving people flexibility to work the way they're used to and know how to work?
So today, for like our build system, we use Jenkins and we have everything kind of built around that. So the freedom to go choose something different is because we have all these automated systems that are set up. people have to learn, that system, the flexibility or freedom to choose new things. We're always open to new technology. If it makes us better, faster, we want to understand that. But on that sort of system side, it's a little more evolutionary rather than revolutionary. Probably one of the biggest changes we made was back in 2016, 2017, when I joined Tools, is we switched to an agile software development methodology. And that was kind of for us, that was a revolutionary change. And I think that's had one of the biggest impacts, to our software development in terms of, productivity, performance, as well as the quality of the end product, right, is following an agile process. So that was an evolutionary change that we made, but or revolutionary change, right? But a lot of the other stuff it's got to be taken, in baby steps and slower.
Yeah, I'm onboarding a team on a new project, and it's tempting to just be like, change all the things, but figuring out what's really important and having them focus on that is a skill set I think I'm learning for myself.
Yeah, I know. I said adopt change, be a failed change, but sometimes you got to be a little bit careful when you do things.
Yeah, for sure. Let's talk a little bit about your work in academia. You lead like the academic development programs. Can you kind of give me an overview of what that entails and what about that you're most excited about today?
Yeah, so this has been evolution probably over 20 years for Microchip. We started with First Robotics when First Robotics came out. And, that led us into working with a couple of colleges here locally in, Phoenix, Arizona, and developing some classes. And about a year ago, what we saw was we didn't feel students were coming out of school, well prepared to enter into, jobs for Microchip, but also for our clients. So it was maybe a little too theoretical, I guess. And so what we wanted to do was how can we integrate more experiential, hands-on learning. And so some of the things that we've done, right, is, we're working on a book, an introduction to microcontrollers book. We have a book on FPGA where it comes with a board and exercises, and students get the opportunity to get their hands on real stuff, right? Not just writing code in the cloud and compiling it with the computer, but actually putting it on real hardware, right? Debugging, for instance, right? You don't learn how to debug there's not a class in university on debugging.
If only.
What's a breakpoint? What's a watch window, right? A lot of students don't, know what that is until they actually, enter the workforce and use those tools. So how do we get exposure to tools, real hardware? And so that's what we're driving, right? Another program that we're doing, is a virtual internship where a student can come and they don't have to be an electrical engineer. They could be a mechanical engineer, but I get a board and I'm able to write some code and debug that. And, it gives, people, again, students the opportunity to go above and beyond coursework and learn different things. So a lot of it's centered around that. And, we're working with a lot of schools, UPenn, we're working with ASU and several other schools on, creating the curriculum and making sure that it's appropriate, for the different levels that, like a 300, 200 level student. And, the book content is also, targeted to that as well. So we look at what reduces the onboarding time for students into a college, right? So if I can learn the tools that are used, if I can learn the devices that are used, and I have hands-on experience with debugging, right? It reduces that onboarding time, which again is time to market for that customer to get their product released.
You mentioned the virtual intern program, and when I saw the numbers for that, I thought it was a typo at first. Can you dig into the broad impact that that's had? Because it's thousands of people.
So we started in India with the government, and it was the All India Council for Technical Education, and they wanted to roll out a virtual internship program to their universities. So we created a curriculum that students can take. First year we trained 8,000 students in India. The second year we trained 8,000 students and actually did train the trainer training for professors. So we have about 120 professors. And now in the third phase, we're actually bringing in hardware labs. So somebody that's taken the virtual training can work with a professor in a lab with real hardware. So they can take what they've learned and then actually use the real hardware. And so students will end up doing about 80 to 100 hours online in the virtual training and then get to go into a lab. So by March of next year, we're hoping to have around 60 of these labs set up in India. Phase 4 of that is how do we take that from India and grow it to the world? And that's what we're doing today through skills.microchip.com, which is providing this platform to now scale this, worldwide.
What an ambitious and exciting program.
We've got a lot of excited schools. I mean, we get daily emails from a school about how do I set this lab up, and we did a workshop here at ASU locally, and just to see the look on the face of a student, they learn how to solder, which is the most basic thing. I solder an LED into a board and it lights up, and just seeing them learn that and then seeing the LED light up, and it's like the look on their face and how excited they are, right? It's so motivating. And how do we bring that experience, to more students? And what did they learn by actually doing something hands-on, right? Rather than just sitting in a class and, typing in an editor and compiling it. It really is a game changer, I think, for students, and for companies that are hiring students.
It's like almost literally a light bulb moment for people. I love that. And it kind of ties back to having a project to be working on, like we were talking about earlier. And what I've seen and what I was thinking about as you were talking about that is the developer, the tinkerers that are best at like learning a thing, they'll pull up a new piece of software or get a new dev board and they'll say, I wonder if I could make this thing out of it or make it do this thing. And having that vision and direction of a project-based learning instead of just like, working through a checklist, which is less helpful, helps you kind of find the parameters of what's possible with your device, with your environment. Super powerful.
And it gives you the curiosity to look more, right? Well, what else can I do with this?
So as we're talking about career development and even like on an internship level, you find yourself now starting out as a double E, but have essentially gotten to VP level at a very well-respected company in the industry. What did you learn as you had that career path? Is there anything you wish you could maybe take back? Or are there any moments where you felt like, oh, that's a thing that went well and I'm going to keep doing that thing?
So obviously you make a lot of mistakes, right? When you're an engineer, right, everything's a 1 or a 0 kind of, right? And
Yeah.
Electronics are nice and tidy, but when you start to work with people and manage people, right, now it becomes, just a rainbow of challenges. So one thing that I really personally struggled with, and the great thing about Microchip is they have training courses for people that are transitioning from, engineers to management, or just anybody that's an individual contributor into management, is how to interface with people, right? So how do you, with your type, if you're a direct or indirect, how do you learn about the person you're talking to, right? And how do I modify my style to be compatible with their style so that we can make progress, right? Because when you have two people that are butting heads, right, you can't really make progress. And you can't really expect, as a manager, you can't expect them to change their style. So I want to look at everything as a 1 or 0, but I have to now look at somebody and say, okay, they're a direct person. And if I'm a direct person, we're going to butt heads. So, I got to choose the hills that I die on, kind of. And so that was a big challenge for me was how do I make that transition? And fortunately, not only did I have the training, but I had good managers, right, that I could model myself after. And, I saw characteristics that, didn't work, and I saw characteristics that did, and I tried to model myself, after, the people that were very successful. And, a lot of it I found was the language that I used, and so when you're talking to somebody and you want to motivate them and include them, right? You use a lot of we. How can we achieve this? What can we do rather than, you're doing this and you're doing this, but how do we go forward? So a lot of it was just language. A lot of it was planning. Like you go into a meeting and, sometimes a lot of people don't think about, well, who am I talking to? What is my plan to choose? So actually doing pre-planning before going into a meeting, I found I'm being more successful. And so that was one big thing that one of my managers that I worked with, his name was Steve Caldwell. He was big on, before you go into a meeting, what is your plan? Not what you're going to talk about in the meeting, but who are you talking to? What type of style do you need to be successful in that meeting? And I found that very useful and very impactful in my progression, from being, individual contributor all the way up to, where I'm at today.
I love that idea of not necessarily like, here's the words I'm going to say, but here's my approach to this meeting because of who I'm meeting with. I will start adopting that for sure.
Yeah.
Can you give some examples of, you're going to have your first meeting with the new team. What's your plan versus you're going to go present to the board? What's your how do you think about those two very different types of meetings?
So if it's a new team, right, I actually start off with, are you married? Do you have kids? What kind of hobbies do you have? Right. So I try to establish a personal relationship with them before ever talking about anything business related. And I feel if I can find something that's in common and we can establish a rapport, right? Like, oh, hey, our kids play soccer. What's your favorite soccer team and things like that. Then you've kind of broken down any kind of wall about, I don't know this person, and hey, he's great. He loves soccer. And so it makes every conversation after that much easier because also, and I generally do care about, everyone that I interact with, but, how are their kids? And I will make notes. And the next time I go talk to that person, it's like, oh, hey, how's your daughter doing? How did she do on this test? Or, one instance is, I traveled and was with a salesperson and his daughter had celiac disease. And so we were talking about food and what a challenge it was for their daughter to go to school and eat lunch. And I visited him probably 2 years later. And, I looked at my notes. And when I went back, he says, oh, how's your daughter doing? Is, everything getting better? And, at the end of the day, what he told me was, he goes, Roger, he goes, I couldn't believe that you remembered, about my daughter and what her situation was. And so, I think building that personal relationship really helps make everything after that much easier.
And coming from a point of authenticity, not like,
Absolutely.
it could easily, and I've seen people do this wrong. So, genuinely caring about people.
It has to be genuine, right?
Yeah.
And I hope that everyone that, I worked with knows that, it's not just a tactic, right, that I use, but I do genuinely think that having a personal relationship makes your professional relationship better. So I do genuinely care about it. And you're right. It has to be absolutely 100%. Going to somebody and saying, hey, good job. What does good job mean, right? I mean, you have to be really specific with the information.
I love how you did X, Y, and Z. I think is kind of one of my go-tos.
Yep.
How about flipping it on the other side, where you're going into a big meeting with the board to propose a direction or something like that? What's going through your mind?
Board meetings can go sideways really quick, right? So I think going into, meetings with executives and boards and things like that, even going into a customer meeting, right? Trying to think about all of the different ways conversations can go. And how do you either plan to go down the rabbit hole with them, or how do you plan to get them, back on track? And having that strategy ahead of time, I think, just prepares you better for that. But that's, in those sort of meetings, whatever you think you're going to talk about, probably isn't exactly what happens in reality. So Daniel, you gotta think about, okay, this can go three ways, and what's my plan for all three ways?
Yeah, coming in prepared and having a contingency plan.
And knowing your data, right? Being prepared and knowing everything about, what you're presenting about. And, a lot of times it's just how you present. If you present confidently and the data, then you might not get all the questions you would if you're kind of tentative. So I think, really knowing what you're doing and being well prepared with your presentation, rehearsing it and things like that, I think better prepare you for those types of conversations.
Well, we're running out of time. So we like to do some lightning round questions
Okay.
at the end of these. Quick questions, quick answers. Question number one, if you had a magic wand and could change the way developers think about, development tools and IDEs, that sort of thing, what sort of mind shift would you kind of magic wand change from a customer user perspective?
I would say, be open to using open source, right? There's lots of tools and lots of content. Great way to get started.
When you went to the corporate Lego store, did the pilgrimage, what did you get? Did you have a kit that's extra special to you?
So I got a space shuttle because at the time, my son loved the space shuttle, right? And I got a Mindstorms kit.
When you worked on the Mindstorm, do you have any favorite moments, other than obviously the cool visit to Lego? Any cool like unlocks where you saw it in use, maybe in a surprising way that really just kind of like really made you happy or joyful to see?
So we saw a video of a student in first Lego League. So for part of First Robotics' first Lego League, we saw them the very first time, saw them using their iPhone to navigate a robot through a course. And it's like the connectivity was just so crisp. And it was just like, we did this right. I mean, that was just, we walked away and said that was perfect.
Looking back in the 30 years you've been in tech, what's been the most surprising development that you've seen?
Honestly, AI, right? The how much AI helps with your productivity, right? I had no belief that we could get to this point, and now I'm like a huge proponent of AI. I think that's had the most dramatic change in terms of the productivity side of things.
And the last question for you, it's pretty common these days to kind of hop companies every couple of years, but you've been at Microchip for a long time. What's keeping you there, and what do you look forward to for your next few years here?
So I started Microchip when they were small, 1,200 employees. And I grew with them to a medium company. I grew with them to 22,000 employees today. And the thing that keeps me here is the culture that we had as a 1,200 person company is the same culture as a 22,000 person company. We have a set of what we call guiding values, right? The number one in the guiding value is employees are our greatest strengths. Those are the exact same guiding values now as they were 30 years ago. And I think it's just that consistency. And also, I love the people that I work with. I get up in the morning and I look forward to coming to work and working with this team, and it's just a fantastic team.
That's very special and rare.
It's been a wild ride. I mean, honestly, there were good times and bad times, and as you probably know, semiconductor industry is up and down, and but I think it's the core fundamentals of Microchip and those guiding values that have kept us and really driven us to the company we are today.
Wonderful. Well, thank you so much for your time today.
Well, thanks, Daniel. I appreciate the invite.
That was Roger Ritchie, VP of Development Tools and Academic Programs at Microchip Technology. Thank you to Mouser Electronics for sponsoring these keynotes. We have a whole lineup of live sessions happening for the rest of the day, so go check those out on the Industry Tech Days page. There's one on magnetics from Coilcraft, that looks super interesting, a silicon carbide MOSFET session from Infineon, and a whole bunch more, so go check out that list. And also, make sure to check out the virtual trade show floor. I'm Daniel Bogdanoff, and I'll see you right back here tomorrow for our next keynote.